So we're now going to look at solving quadratic equations. Now there are four ways of solving quadratic equations. We can use the graph, we can factorize, we can use the quadratic formula, or as in the previous video, we can complete the square. So a root of a quadratic, where we've got it in functional notation, is a value of x for which f of x equals 0. So we want to solve the quadratic shown using the graph. And in the graph, we've got the quadratic y equals x squared plus 4x minus 12. So we know that to solve this equation, we have to equate that graph to 0. So x squared plus 4x minus 12 is going to equal 0. So that's when our y coordinates are 0. So those are the 2 points where it crosses the x-axis. And so our values are going to be x equals -6 or x equals 2, reading it from the graph. Our next examples, we're going to use factorizing. So we want to express each quadratic as a product of factors. So the first one, we have a highest common factor. We've got 6x squared minus 12x. So the highest common factor is 6x upon x minus 2. And if we wanted to solve that, then we would equate that factorized format to 0. So to solve, we're going to have 6x upon x minus 2 equals 0. Now we know anything times 0 is 0, so if we equate each part to 0, we've got 6x equals 0, so x equals 0, or x minus 2 equals 0, so x equals positive 2. The next one, we've got 16x squared minus 25. That's a difference of two squares. We know our factorized result is going to be two brackets with the square root of the first term and the square root of the second term separated by a plus and a minus in each bracket. So our first term is going to be 4x, and we're going to have minus 5 in the first bracket. We're going to have 4x plus 5 in the second bracket. Now to solve, we need to equate that to 0. So we're going to get 4x minus 5 upon 4x plus 5 equal to 0. And then we're going to equate each bracket. So 4x minus 5 equals 0, or 4x plus 5 equals 0. And then we need to rearrange, so we get x equals 5 over 4, or x equals negative 5 over 4. So next we've got 6x squared plus 7x minus 5. So here we've got a trinomial. And because we've got a non-unitary x squared term, we're going to use the magic number technique. So if we rewrite that as 6x squared plus 7x minus 5, our magic number is the 6 multiplied by our negative 5, which gives us negative 30. Now we want to find the factors of that negative 30. They're going to add together to give us plus 7. And because we've got a negative 5 at the end, we know that our brackets are going to have different signs. So we're going to have a positive 30 and a negative 1. That gives us plus 29. That's not going to work. Plus 15 and minus 2 gives us plus 13. That's not going to work. Plus 10 and minus 3 does give us the plus 7 that we want. So we're going to substitute that back in place of the 7x. So we'll get 6x squared plus 10x minus 3x minus 5. Now we want to factorize the first two terms. So the highest common factor is going to be 2x. And inside our bracket it's going to leave us with a 3x plus 5. And then we want to factorize the second two terms, the minus 3x minus 5. And we want to have that duplicate bracket of 3x plus 5. So we're going to take out a negative 1 to give us our 3x plus 5 bracket. So our brackets are 2x minus 1 upon 3x plus 5. And to solve that trinomial, we equate those brackets to 0. So we've got 2x minus 1 upon 3x plus 5 equals 0. And so 2x minus 1 equals 0. Or we've got 3x plus 5 equals 0. And if we rearrange to solve, we get x equals a half, or x equals negative 5 over 3. Now when we're solving with two terms, there are two methods. So if we want to find the roots of f of x equals 3x squared minus 75, We want to equate it to 0 to find the roots and use our factorizing checklist. So we've got f of x equals 3x squared minus 75 equals 0. We're looking for a highest common factor, so we've got 3 upon x squared minus 25 equals 0. And we can divide both sides by that 3 to cancel it out. Now we've got a difference of two squares, so we're going to have x minus 5 upon x plus 5 equals 0. And then we're going to make each of those brackets equal 0. So x minus 5 equals 0, or x plus 5 equals 0. So we get x equals 5, or x equals negative 5. The other option is to do rearranging and isolate our x squared term. So we've got 3x squared minus 75 equals 0. We're going to add 75 to both sides to get 3x squared equals 75. Divide both sides by 3 to get x squared equals 25. And then we're going to remember that we're going to have a plus or minus solution when we square root that 25. So we end up with exactly the same solutions, just done in a different way. X equals plus or minus 5. Now the roots of ax squared plus bx plus c equals 0 when a isn't 0 are given by the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is not given on the higher formula sheet, so you need to remember it. So if we want to solve y equals 3x squared plus 2x minus 6 to 1 decimal place, the 1 decimal place is a clue that we're going to have to use our quadratic formula. So the first thing we want to do is write it out. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we need to work out what our values for a, b, and c are. So a is our coefficient of our x squared, so that's 3. B is the coefficient of our x term, so that's a positive 2. And c is our constant term, and that's going to be negative 6. So now we want to substitute those values into our quadratic formula. So x is going to be equal to negative, and our b value is 2. And that's going to be plus or minus the square root. And again, our b value was 2, so it's going to be 2 squared. And then we're going to be subtracting 4 multiplied by our a value, which is 3. And we're going to multiply that by our c value, which is negative 6. And we're going to divide the whole thing by 2 multiplied by our a value, which again was 3. So we're going to end up with 2 roots. So we're going to end up with x equals negative 2 plus, and our square root of 2 squared minus 4 times 3 times the negative 6 gives us a square root of 76. And all of that's going to be divided by 6. And our second root is going to be negative 2 minus the square root of 76 all over 6. Now it's asking us to round to 1 decimal place, so remember to give unrounded answers. So the first root is going to be 1.119, and that's going to round to x is approximately 1.1 to 1 decimal place. And our second root is going to be equal to negative 1.786, and so on. And so that's going to round to x equals negative 1.8 to 1 decimal place.